Chapter 4 revision. So we're looking at data handling, we're looking at representing data in two-way tables, bar charts, pie charts, line graphs, and so on. We're only going to cover a few of them, and we're going to start off today by looking at two-way tables. A two-way table is quite a good way to put a lot of information that makes it easier to read, and you quite often get to do one. It's quite useful to use one when looking at more difficult probability questions, for example. So here you can pause the video, read the question and see if you can answer this question. So Peter, the factory manager, planned to install a new hot drinks machine for the factory workers. He decided to fill it with tea because he thought tea was the most popular hot drink. However, the workers did a survey to check their preferred hot drink, and each person could choose hot chocolate, tea or coffee. 8 women wanted hot chocolate, 16 workers wanted tea, of which 7 were men, 10 men and 12 women wanted coffee. There were 25 men in total. Was Peter correct? So we've got two different categories. We've got a category, one is our drinks, and the second category are our workers, which are split into male and female. So here I've drawn the table, and I'm going to go through now and see if I can fit each of all the information I'm giving into the correct category. So we're told that 8 women wanted hot chocolate. So that's our first statement. 8 women wanted hot chocolate. So I can put an 8 in there. 16 workers wanted tea. So 16 workers, that's in total, wanted tea. So I did have to include my totals common for both men and the number of hot drinks. So 16 in total wanted tea, of which 7 were men. So 7 of those 16 were men. 10 men and 12 women wanted coffee. So that's 10 men in the coffee category and 12 women wanted coffee. And we're told there were 25 men in total. So I've put all the information in, and so basically what we need to do, if we've got a total, we're looking for any row or column which has just one square missing, and we can use the information to work out the missing total. So I know here there's a total of 25. I've got 17 men altogether, so 25 men in total. I've got 17 who've chosen tea and coffee altogether. So that will leave me with 8 who must choose top chocolate. So that line will add up to 25. Here, 16 in total choose tea, 7 of which were men. So that means that 9 women must have chosen tea. This total here, 10, gives me 22, and the number of choosing chocolate altogether is 16. And my total number of women, 8 and 9 is 17, 27, 28, 29. So that'll give me a total of 54. Just checking my horizontal total, that would give me 16, 16 is 32, 40, 52, 54. So my overall total is 54. So was Peter correct? Now Peter said that he thought tea was the most popular drink. Now if we actually look at this table, we can therefore say, well, no, Peter was incorrect. Coffee is the more popular. So a two-way table is a good way of putting all the data you're given into a table to make it easier to interpret. If I were to plot a pie chart showing the whole group, 128 boys, what would its radius be to be in proportion if the radius of my original pie chart for 32 boys was 5 centimetres? So I've got a radius here. I know that that radius there is 5 centimetres, and I'm drawing another pie chart. I'm keeping everything in proportion, and I need to work out what this radius is here for the larger pie chart. This pie chart represents 32 boys, and this larger pie chart is going to represent 128 boys. Now, the area, you've got to remember the area of the pie chart is representative of 32 boys. So and the area of this pie chart is 128. It represents 128 boys. So I can see from here that my area scale factor is going to be multiplied by 4. So my linear scale factor, because we need to work out what the radius is. So if you like, 4 is 2 squared. So my linear scale factor is going to be the square root of 4, which is 2. So my radius, therefore, 5 times 2 will give me 10. So the radius in my larger pie chart, representing 128 boys, is going to be 10 centimetres. Here we've just got a quick recap of some terms that you should be aware of. So the mean of a set of data is the total of all the values divided by the number of values. The mode is the value that occurs the most often. The median is the middle value. So when we put all the data in order, smallest to largest, the median is the middle value. If there is an even number of data items, then we take the middle pair and work out the average of them, so the mean of the middle values. And the range is the largest value minus the smallest value, so the difference between the largest and the smallest value. You do need to be aware that we can have outliers. Now, outliers are values that lie outside most other values of the data set. So in this data set here in the example, 16 doesn't fit in. So we can say that 16 is an outlier. And the mean and range can both be affected by the outlier. So if you look at the range here, if we include the outlier, we would have a range of 15. But if we ignored the outlier and missed it out, we would have a range of 3. Now here we have what we call a frequency table, and we are sometimes asked to work out the mean using a frequency table. Now here we're looking at the average number of pets a household has. So I'm going to call this category my X value, and the frequency is our F value, and the last column we want to work out the product of these, so we want to work out what F times X is, our Fx column. So looking at this example here, 0 times 11 is 0 times 11 is 0, 1 times 23, 2 times 13, 2 3s are 6, and 1 4 is 4. And that total will give me 59. Now to work out the mean, we want the total of the F times X column, which will be 59, and we want to divide that by the total of the frequency column, which is 50. And putting that down as a decimal would be 1.18. Now it doesn't matter that your answer is a decimal for the mean, that's fine. So we can say the mean number of pets is 1.18. Now the mode is the item that has the most in it. So the mode, you need the category with the highest frequency. So in this case, Our highest frequency here is 23, so our modal number of pets is 1. So that's our modal value. And our third question asks for the range. Now the range is the difference between the highest and the lowest possible values. So our range here is going to be 4 minus 1, 0, which equals 4. The range is a measure of how widely spread the data is. However, the range can be affected by outliers, as we've already said. So a better measure of spread is what we call the interquartile range. So it doesn't take, so removing an outlier, or if there is an outlier there, leaving that, if we work out the interquartile range, it will not be affected by any outliers in the data. So the interquartile range, we say, is the upper quartile minus the lower quartile, and you'll sometimes see it written as IQR. The upper quartile is our Q3, and our lower quartile is our Q1. And our median, just making a point here, our median is Q2, our second quartile. Not exactly relevant here, but worth knowing. To work out our median, or the lower quartile, or our upper quartile, you need to put the data in order, going in ascending order. So the first quartile, it's the median of the lower half of the data, and the upper quartile, in other words, that's the median of the upper half of the data. So we've been asked to work out the mean, mode, range or interquartile range for each set of data. So looking at the girls, so this is going to be my x value. Here's my frequency. To work out the mean, we need to work out f times x. So 1 times 3 is 3, 2 2s are 4, 3 1s are 3, 4 1s are 4, and 5 times 0 is 0. So our total frequency is 3, 4, 5, 6, 7 girls, and our total fx is 7, 8, 9, 10, 11, 12, 13, 14. So the mean for the girls is going to be 14 divided by 7, which is 2. The median, now our median is our n plus 1 over 2 value. So if we've got 7 here, so that's going to be our 8th over 2, which will give me my 4th value. So counting down here, if we look at the frequency, we've got 3 values. That means we've got 1, 1, 1. So our 4th value is going to be 2. So we've got a mean of 2 and a median of 2. The range for the girls, here is the largest possible distance, which is 5, minus the smallest possible distance, which is 1. So we have a range of 4. And then it asks for the interquartile range. So I need to work out what Q1 is. Now Q1 is quarter of the way along, so it's n plus 1 over 4 value. So quarter of the way along, so that will give me n plus 1, so 7 plus 1 is 8, divided by 4, which means 2, so I want the second value. And the second value along here, if we've got 3 ones, the second value is going to be a 1. The upper quartile is our Q3, 3/4 of the way along, so it's 3 times n plus 1 over 4, which is 3 times 8 over 4, so I want the 6th value. Counting down the frequency, 3 plus 2 is 5, so 5 pieces of data here. So our sixth piece of data is going to be a 3. So our interquartile range for the girls is going to be 3 minus 1, which equals 2. So here I've got all the information for the girls. Now doing the boys, I'm going to take the data, it's not in order, so for the boys I'm going to order the data first. So I'm going to have a 3, got 2 3s, I've got 2 4s, and I've got 1, 2, 3, 4 5s. So the mean, and just remember the mean, you might see in the notation, could be an X bar or a letter with a bar on top means mean. So our mean here, if we add them all up here, we haven't got a frequency table, so we could just add them up. 3 and 3 is 6, plus 4 is 10, 14, 24, 34. So our mean is going to be 34 divided by 1, 2, 3, 4, 5, 6, 7, 8, divided by 8. So that will give me 4.25. The median is the middle value once they're all put in order. So 1, 2, 3, 4, 5, 6, 7, 8. So the middle value here is going to be a middle pair. So our middle value here is going to be 4.5. Add them together, 4 plus 5 is 9, divided by 2 gives you 4.5. The range is the difference between the largest and the smallest. So our range here is going to be 5 minus 3, which equals 2. So I've got my 3 pieces of data so far, and now I need the upper quartile and the lower quartile. So the upper quartile, or lower quartile, we'll do Q2, 3, 1 even. So my lower quartile is going to be between 3 and 4, so it would be 3.5. My upper quartile, Q3, is going to be between 5 and 5. So my interquartile range is going to be 5 minus 3.5, which equals 1.5. So I've worked out all that I've been asked to work out, and by calculating I need to compare each set of data. So you need to compare what we call our measures of location, so things like the mode or the mean, and a measure of spread, so how the data is spread. So you should make a comment about each of those things. So by comparing the mean, I can see that on average, the boys ran further on average than the girls, but the range shows that the girls' distances were more varied than the boys. So looking at the mean, we have a mean there for the boys of 4.25 and the mean for the girls is 2. So the boys ran further on average, and if we compare the medians as well, and we can see here that the ranges, the interquartile ranges, are 1.5 for the boys and 2 for the girls and 1.5 for the boys. So the girls is different, so slightly more spread out. And if you look at the range, actually, the interquartile ranges are quite close, but the range for the girls is 4 and the range for the boys is 2. So the girls is more varied. The next part, the last part of this chapter, looked at bar charts and histograms. When do we use a histogram? Well, we use a histogram when our class widths are all different, so they're not all the same. They have different class widths. And for that, we then need to work out what the frequency density is. So on this slide here, so here we've got the histogram, and the class widths are all different. So the first class width goes from 55 to 75, which is 10, and then the second bar has a class width of 5. So in this case, we then need to go on and work out the frequency density, which we plot along the y-axis here. So frequency density goes on the y-axis and then our other variable on the x-axis. And you need to remember here that the area of the block represents the frequency. So if I was then asked to work out the frequency, if I work out the area of this block, so 10 times 0.2, 10 times 0.2 is 2, so I know that the frequency of that block would be 2. Another point you need to be aware of is that a bar chart with equal widths is only suitable for discrete data, and a histogram must be used for group continuous data. We plot the frequency density on the y-axis, and the area of each bar represents the frequency. And you need to know that frequency density equals frequency over class width, and we can use this formula to rearrange it. So if we need to work out the frequency, we could therefore say frequency density times class width will give us the frequency. So in other words, this actually is the area of the bar, which is what we said earlier. The area of the bar represents frequency, but that's why if you rearrange the formula, that's what you get. So here we've got 50 overweight adults who tried out a new diet, and the table shows the amount of weight they lost in kilograms in 6 months. So straight away we can see here that the first class has a class width, so 0 to 4 has got a class width of 4. 4 to 6 has a class width of 2, so we know straight away if we're going to have to draw a graph, it's going to have to be a histogram. We're going to need to work out frequency density. Class width of 2, 2, 5 and 10. So frequency density equals frequency over class width. Learn it, you're not given it. So 12 divided by 4 will give me 3, 13 divided by 2, 6.5, 11 divided by 2, 5.5, 7 divided by 2, 3.5, 5 divided by 5 is 1, and 2 divided by 10, 0.2. And you then need to sort out a suitable scale on the y-axis for that, and then label the x-axis accordingly for the class width. So if I was doing that, you would label your class width. You could go up in 2, so 2, 4, 6, 8, 10, 12, 14 and so on, and I would then have that maybe going up to 6.5. You could go up in 1 using your graph paper. And looking at the first one, 0 to 4 has a frequency density of 3. So 0 to 4 will go up to 3. And then 4 to 6, it's going to be wider, will go up to 6.5. and so on. And if we turn over the page and get the graph here. So here we have our histogram. We've got the frequency density on the y-axis, weight loss on the x-axis, label both your axes, give your graph a title. So really check when you're doing these sort of questions, when you're asked to draw a bar chart or a histogram, check the class widths, if any of them are different, work out the frequency density, and you may have to sometimes add an extra column on the table to do that.